Welcome YouTubers to another episode in my Grammar Hero series. In today's video, we're going to talk about systems of equations. More specifically, we're going to work out some word problems that have a high likelihood of appearing on the ASVAB. In case you missed it, I posted a video yesterday in which I discussed two methods, notably the substitution and elimination methods to solving system of equations. Today we're going to use either one of those two methods to solve these problems. Before we get started, I just want to point out that the hardest part for today's video is taking a word problem and converting it into a system of equations. So as you watch this video, please try to pause the video before I work out a problem. And more specifically, try to take the equation or the word problem that's given and write it into a system of equations. More often than not, if you can accurately convert a word problem into a system of equations, you can get these questions right. So all that said, let's go ahead and get started with today's video. The first question says, find the value of two numbers if their sum is 12 and their difference is 4. When I deal with systems of equations, I always like to use x and y as my variables. It helps remind me that we're dealing with equations of lines. But that said, you can use any two variables that you want. And I'll try to use different variables as we work through this video just to mix it up for you. But this first one says, find the value of two numbers of their sum is 12. So if I let x refer to one number and y refer to the other number, that would look like this. X plus y equals 12. In other words, the sum of these two numbers is 12, and the difference of those two numbers is 4. So that would be x minus y equals 4. So as you can see, we have our system of equations. Now we just got to pick one of the two methods to solve it. I'm going to use the elimination method. More specifically, I'm going to add this second equation to this first equation to get rid of the variable or eliminate the variable y. So let's see what that looks like. Again, I'm just going to write those equations over here so I can have some space. I'm just copying this first equation since I'm not changing anything there. And then I'm just adding this second equation to it, and that's minus y equals 4. And we'll go ahead and add these two equations together. X plus x is 2x plus or positive y minus y becomes 0. And then we have 12 plus 4, which is 16. Now we're solving for x. Divide both sides by 2, of course, to get x by itself. This crosses out. We're left with x equals 16 over 2, 16 divided by 2, which is 8. We're almost done. We found one of the numbers. That said, we have to find the other number. So if you recall from yesterday's video, one of the final steps in the algorithm to solve system of equations using the elimination method is to take one of the variables and plug it back into the original equation. And you can plug it in either the first one or the second one. Both will work. So I'm going to take this x, in other words, and plug it in right there for x. And that will allow me to solve for y. So let's go ahead and do that. Let's do that off to the side here. I'm just going to copy x plus y equals 12 over here. Again, we're substituting x in where we see x in the original equation. That is, this becomes 8 plus y equals 12. Again, we're solving for y now, so we're going to subtract 8 from both sides. 8 minus 8 is 0. That leaves us with y equals 12 minus 8, which is just going to be 4. And as you can see, we went ahead and satisfied this question. That is, we found the two numbers, namely 8 and 4. As I mentioned yesterday, it's always a good idea to check your work. And to do that, you can simply plug these x and y values into original equation and see if they make a true statement. So let's plug in these x and y values to the second part of the second equation. So we have x minus y equals 4. Of course, we know x is 8 and y is 4, so let's plug those in. We have 8 minus 4 equals 4. 8 minus 4 is 4. 4 equals 4, so that's a true statement. We know that we did this problem correctly. Again, this is a fairly simple one, and as you probably agree, the hardest part was going from the word problem to a system of equations. So you'll get a lot of practice doing that in today's video. The second question says the difference of two numbers is 3. Their sum is 13. Find the numbers. So this is a very similar question to the first one, and you will see something like this on the ASVAB more than likely. The difference of two numbers is 3. Again, I like to use x and y, but just for practice, let's use a and b. So a minus b is 3. Again, that refers to the difference of two numbers being 3, and the sum of them, a plus b, is 13. And just like that, we took the word problem and translate it into a system of equations where we can use either the substitution or elimination method to solve. In this case, I'm going to add this first equation to this second equation, which will prompt the variable b to drop out or eliminate the variable b and allow me to solve for a. And then using backfilling, I can solve for b. So let's go ahead and do that. I'm going to write this bottom equation up top since we're doing addition. A plus b equals 13. A minus b equals 3. Again, we're adding these equations. A plus a is 2a. B minus b is 0. And 13 plus 3 is going to be 16. Let's divide both sides by 2 to get a by itself. This crosses out and leaves us with a equals 16 over 2, which is 8. Now, if you recall, the next step in the algorithm to solve this system of equations using elimination is to take this a and substitute it back into either of the two original equations. In this case, it will be easier if I plug a in to this equation. So let's go ahead and do that. Again, we have a plus b equals 13. Again, we know a is 8, so let's plug that in where we see a. 8 plus b equals 13. Solve for b, we have to take 8 away from both sides. That leaves us with b equals 13 minus 8. 8, 9, 10, 11, 12, 13. That's 5. So as you can see, we've now answered this question. Namely, one of the numbers is 8 and the other number is 5. That said, it's always a good idea to check your work. So to check your work, you simply plug these two variables back into either of the two original equations. Let's go ahead and plug them into this first equation, which I'm just going to rewrite over here. A minus b equals 3. Again, we know a is 8, so let's plug that in. B is 5. 5 minus 3 is 3. 3 equals 3. That's a true statement. So we know using our system of equations as well as the elimination method, we were able to get this question correct. Okay, so those are some easy problems that appear on the ASVAB. Again, the hardest part is recognizing you're dealing with a system of equations, and beyond that, translating the word problem into a system of equations that you can then solve. All right, so this question says, the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Find the price of a senior citizen ticket and the price of a child ticket. The key to realizing you're dealing with a question that's going to require you to use a system of equations to solve is the fact that it's asking you to find the price of 2 different variables, which you can only do using a system of equations. In this case, we have to find the price of a senior citizen ticket and a child ticket. The first thing I'm going to do is refer to senior citizen tickets as X and the price of a child ticket as Y. And if we go back into the question, we can see they sold 3 senior citizen tickets, that's X, and 1 child ticket, Y, for a total price of $38. So that looks like this in terms of an equation. 3X plus Y equals 38. And similarly, we can see that on the second day, they took in $52, which would go over here by selling 3 senior citizen tickets, that's 3X, and 2 child tickets, 2Y. And thus, we've created a system of equations we can use to solve this problem. Right now, we have to decide whether we're going to use the substitution method or the elimination method to solve it. And as far as I can tell, it looks like it's going to be easiest to use the elimination method. More specifically, I can tell that if I multiply this top equation by -1 and add it to this bottom equation, that's going to eliminate the x variable, which is going to allow me to solve for the y variable very easily. So let's go ahead and do that. We have 3x plus 2y equals 52. Again, I'm just copying this bottom equation over here so my work stays organized as I add these two together. And then I'm going to multiply everything here by this -1. So 3x times -1 is -3x. Y times -1 is -y. And 38 times -1 is -38. Now let's add these two equations together. As we can see, 3x minus 3x is 0. 2y minus y is just y. And 52 minus 38, in case we can't do that in our head, let's do it. Let's work it out the old-fashioned way here. 2 minus 8 we can't do. We have to borrow. This becomes 4. This becomes 12. 8, 9, 10, 11, 12. 12 minus 8 is 4. 4 minus 3 is 1. So we can see that y, which refers to the price of a child ticket, is $14. Now, if you remember in the elimination method, the final step in the algorithm is to take this variable that you just solved, namely y in this case, and plug it back into one of the original equations to solve for the other variable, which would be x in this case. It's going to be easiest to plug it into the first equation. Remember, this first equation was 3x plus y equals 38. So I'm going to take this y and plug it in where I see y in the first equation. So we have 3x plus 14 equals 38. Again, we're solving for x now, so we're going to subtract 14 from both sides. That's going to cross out and leave us with 3x equals 38 minus 14. In case we can't do that in our head, let's work it off to the side. 8 minus 4 is 4. 3 minus 1 is 2. So we can see we have 3x equals 24. Again, we're solving for x at this point, so we're going to divide both sides by 3 to get x by itself. That leaves us with x equals 24 over 3, or 24 divided by 3. 24 divided by 3, of course, is 8. And if you recall from yesterday, it's always a good idea to check your work just to make sure you did it correctly. And to check your work, you can simply plug these two variables, namely x and y, into either of the original equations and see if it makes a true statement. So again, working with the first equation, we had 3x plus y equals 38. Plug in x and y accordingly. 3x is 8, y is 14, equals 38. 3 times 8 is 24, plus 14 equals 38. 24 plus 14 is 38. 38 equals 38, so we know that's a true statement, and therefore we know we did this question correctly. So that's that one. All right, this next problem is going to be somewhat challenging, but it's not impossible. If you're going to score somewhere between 85 and 99 on the ASVAB, you definitely want to know how to approach this problem. That said, if you can solve a system of equations, this one shouldn't be too much harder for you to do. So everyone should be able to do this one. The question says a boat traveled 210 miles downstream and then 210 miles back. The trip downstream took 10 hours. The trip back took 70 hours. What is the speed of the boat in still water? What is the speed of the current? So again, one clue that you're dealing with a system of equations is the fact that the question is asking you to solve for two variables, namely the speed of the boat as well as the speed of the current. Let's do a little visual in this case to make it a little easier to understand. So let's say we had this stream that we were traveling in. We had this boat, and this is going to be a top view of the boat. Let's say this is our boat. Okay, the total distance traveled is going to be 210 miles. That's downstream, one way downstream, and then let's make this our upstream. Again, same distance. So in this case, and let me call this downstream, and this is going to be upstream. In this case, the boat is going 210 miles downstream. The current, in other words, is going this way, and the boat is traveling this way as well. In other words, the current is pushing the boat, which is going to make its rate of speed faster. Now, when the boat travels upstream, it's going this way, whereas the current is going against it. In other words, that current is pushing against the direction of the boat, which will slow it down. Okay? So, in light of that, we have to figure out how to write this equation such that we can use the system of equations to solve it, but we also need to account for this new variable, namely the speed of the current. Well, in this case, we're going to use a concept that we used that I've mentioned in pretty much all of my videos, namely the concept of distance equals the rate of something times the time it travels, that is d equals rt. And more specifically, we're going to add in the variable current. In this case, I'm going to call current C. So we're actually going to be dealing with 1, 2, 3, 4 variables. To illustrate this algebraically, this condition where the boat is being sped up by the current, I'm going to say the rate of speed of the boat is sped up by the current. That is, the current speeds up its rate. And to illustrate this condition algebraically, I'm going to say the rate of the boat is slowed down by the current. That is, the current takes away speed from the boat. Now, whenever you're given these problems involving distance, rate, and time and system of equations, it's always helpful to set up a little chart so that you can keep your work organized. And one thing I like to do is I like to rewrite the equation such that it looks like this: RT equals D. Again, it's the same formula. I just have my distance on the right-hand side, which will help us set up equation later. So I'm going to call this our t, which stands for time. This one's going to be our rate of speed, r, and this one's going to be our distance. I'm going to call this one downstream, so I'll put a d there. I'm going to call this one upstream, so I'll put a u there. We're told that downstream, the trip took 10 hours, so we know our time's going to be 10 there. Whereas upstream, our back took 70 hours, so we'll put 70 there. We know the rate of speed insofar as it's related to the current. So the rate for downstream is r plus c. And similarly, we know the rate of speed insofar as it relates to upstream. That's r minus c. And we're also given the distance. Both distances are 210. As I mentioned over here, you go downstream 210 miles, and then you go the same 210 miles upstream. So now, let me go ahead and get rid of our drawing since we're going to need the space to do the work. Now we have to do some algebra to come up with a system of equations, and it's fairly simple. We're just going to take these and multiply these together. We have 10 r plus c equals 210. Again, this is just the distance formula. And then for this one, we have 70 r minus c equals 210. Okay. So we have a choice at this point. We can distribute this 10 to this r and this c, and this 70 likewise to this r and this c, which will give us a system of equations. Or we can simplify these equations to make the math a little bit easier in the end. That is, I can take this whole equation and divide it by 10. And in doing so, let me go back and rewrite that. I can take this side of the equation and divide it by 10. And what I do to one side, I'll have to do to the other side of the equal sign. That would cross this out, just leaving me with r plus c. And that would leave me similarly with 21 or 210 divided by 10. And if we do the math on that, we can see that we can cross out these zeros, leaving us with 21 divided by 1, which is just 21. And similarly, if I wanted to reduce this bottom equation, I can take this half of the equation and divide it by 70. And what I do to that side, I have to do to the other side of the equal sign. 70 divided by 70 would cross out, just leaving me with r minus c. And then we would have this left, 210 divided by 70. We can cross out these zeros, which leaves us with 21 divided by 7, which is 3. And just like that, we've gone from the word problem to accounting for our variable c, which refers to the current, to a system of equations that we can solve this problem, that we can use to solve this problem. Now we just have to decide what method we're going to use. It's going to be very easy to use the elimination method, because if I add this first equation to this second equation, we can see that the variable c will be eliminated. So let's go ahead and do that right here. Again, this first equation is r plus c equals 21. We're going to add that to the second equation, r minus c equals 3. When we add those, we get r plus r, which is 2r. C minus c is nothing, and 21 plus 3 is 24. Now we're just solving for r, so we're going to divide both sides by 2. This crosses out and leaves us with r equals 24 divided by 2, which is 12. This r refers to the rate of the speed of the boat in still water. Okay, so we've solved for that. Now we just need to find the speed of the current, And if you remember the next step in the algorithm to solving a system of equations via elimination, it's to take this variable that we solved for and add it back into the original equation. So I'm going to take this r and plug it into this first equation here, and then that will give me c. So if we do r plus c equals 21, plug in r accordingly, 12 plus c equals 21. To get c by itself, we're going to subtract 12 from both sides. That's going to cross out and leave us with c equals 21 minus 12. If we can't work that out in our head, let's do it off to the side. 1 minus 2 we can't do. We have to borrow. This becomes 1. This becomes 11. 11 minus 2 is 9, 10, 11, so it's going to be 9. So we can see the speed of the current is 9. And just like that, we solved this one. That is, we found the speed of the boat in still water, as well as the rate of the current. And as you can see, the current really speeds you up when you're going downstream. It takes 10 hours to cover 210 miles. And going against it really slows you down. It takes 70 hours to cover those 210 miles. Okay, so that was that one. Pretty straightforward. I think everyone can handle that one once they see it a couple of times. Again, the hardest part of this problem is realizing you have to incorporate the distance formula into your equation. And also, in addition, you have to account for the speed of the current, which you have to use a small algebra, which you have to represent algebraically for this to work. Okay, 2 more problems and we'll be done today. This next question says the state fair is a popular field trip destination. This year, the senior class at high school A and the senior class at high school B both plan trips there. The senior class at high school A rented and filled 8 vans and 8 buses with 240 students. The high school B rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students as did the buses. Find the number of students in each van and bus. So again, a clue that you're going to need a system of equations to solve this one is the problem's asking you to solve for 2 different variables. In this case, I'm going to call the number of students in each van V and each bus B. Again, you can assign whatever variables you want. More often than not, I use X and Y, but we're going to use V and B in this case. And if we go back into the problem, we can see the senior class at high school A rented and filled 8 vans V and 8 buses B with 240 students. So that looks like this in terms of an equation. 8V plus 8B equals 240. And if we look at the final part, we can see it says they filled 4 vans and 1 bus with 54 students. So 4V plus B equals 54. And just like that, we took this word problem, assigned some variables to it, and then wrote 2 equations we can use to set up a system of equations to solve this problem. At this point, we have to decide how we're going to solve this problem, and we can either do so via substitution, which we haven't done yet in this video, or elimination. Honestly, elimination is probably your best bet. It's the easiest to do. And in this case, we can see if we take this bottom equation and multiply it by a factor of -8, we can eliminate the variable 8b. So let's go ahead and do that. I'm just going to copy this first equation over here. 8v plus 8b equals 240. The hard part about this problem, I'll be honest with you, is the fact that we're going to be using bigger numbers than we have so far in this video. But that said, just work with the big numbers. On the ASVAB, you're going to see numbers that are small and big. So you got to practice working with small and big numbers to do well. Negative 8 times 4v is negative 32v. Negative 8 times b is negative 8b. And 54 times negative 8, well, we know it's going to be negative, but in case we can't do that one in our head, let's do 54 times 8. This is where you don't want to make a mistake doing this simple math. 4 times 8 is 32. We got to carry our 3. 5 times 8 is 40, plus 3 is 43. Let me just check that real quick. 32, carry the 3, 40, 43. Okay, good. So this is going to be negative 432. Again, we're eliminating variable b by adding these two equations together. Negative 32v plus 8v is going to be negative 24v. 8b minus 8b is nothing. And that leaves us with 240 minus 432. We got to figure out what that is. So the way to do that is to write it like this. 432 minus 240. And just know that our result, since negative 432, is going to be negative. 2 minus 0 is 2. 3 minus 4 we can't do. We have to borrow. This becomes 3. This becomes 13. 4 plus 9 would give you 13, so we know this is going to be 9. And 3 minus 2 is 1. So we can see that this is going to be negative 192. And as you know, we're solving for b. So let's go ahead and divide both sides by negative 24. That's going to cross this out and leave us with v equals negative 192 divided by negative 24. A negative divided by a negative is going to be a positive, so we know that our answer is going to be positive. That said, we have to do long division to figure it out, so let's go ahead and do that. Again, we have 192 divided by 24. Now, the way I would do this mentally is I would round 24 up to 25 and use what I know about 25 to try to estimate what this answer is going to be. 25 times 4 will give me 100. 25 times 8 will give me 200. So I'm going to say 24 times 8 will give me 192. Let's see if that's right. 24 times 8. 4 times 8 is 32. Carry the 3. 8 times 2 is 16, plus 3, 16, 17, 18, 19. So, in other words, 24 times 8 is 192. So we can see there's going to be no remainder. In other words, negative 192 divided by 24 is going to be 8. Okay? So in other words, each van can carry 8 students. And again, negative divided by negative is a positive, as I mentioned already. Now, the next part in solving a system of equations using the elimination method is to take the variable you just solved for and plug it back into one of the two original equations. I'm going to use this equation right here since it's easier to work with. Let me go ahead and write that down. It's 4v plus b equals 54. And again, we know what v is, so we're going to plug that in accordingly. 4v is 8, so let's plug that in. Plus b equals 54. Now we're solving for b. 4 times 8 is 32, plus b equals 54. Subtract 32 from both sides. This crosses out and leaves me with b equals 54 minus 32. Let's do that off to the side. 4 minus 2 is 2. 5 minus 3 is 2. So b is 22. In other words, let me make sure I did that right. 4 minus 2 is 2. 5 minus 3 is 2. In other words, a van can carry 8 students, whereas a bus can carry 22 students. You can check that by plugging it into an equation, but you can see right here we have 4 times 8, 32, plus 22 will give us 54. So we know this works. Okay. So that's that one. Again, hardest part is to go from the word problem to a system of equations and then solve the system of equations. And in this one, we had a lot of multiplication as well as long division to do, which is good because it's practice for the rest of the ASVAB. Final question says, while preparing for an upcoming race, a marathoner ran 336 miles down, that should say downhill, and then back, that is uphill. The run downhill took 12 hours. The trip back, which was uphill, took 14 hours. What was the speed of the runner on flat ground? Okay, so let's start with an illustration. This runner is going up and down the same hill. Okay, and the hill is 336 miles long. In this instance, the runner is going downhill, and if you've ever ran downhill, you know that this will speed you up, whereas if you have to run uphill, which they're going to be doing in this one, it's much harder, and that's going to slow you down. Okay, so like in the problem where we had the question about the boat going upstream and downstream, we have to understand that the hill itself is going to either slow you down or speed you up. And like in the problem where we were trying to solve the rate of the speed of the boat in still water, we're going to have to make use of the distance formula to solve this question. But before we do that, let's go ahead and talk about how the gradient, which I'm going to call G, affects the runner in terms of what we need to set up this equation algebraically. Again, we're dealing with the rate of the runner. When they're going downhill, that gradient is going to speed them up. And similarly, when they're running uphill, that gradient is going to slow them down. So algebraically, that looks like this: rate plus G, speeding up the rate minus G, which is going to slow them down. So let's set up our chart. And again, you know I like to set it up like this. R times T equals D. So let's go ahead and do that. And let's call this one downhill and uphill. And I'm going to put time here, rate here, and distance here. This is going to be downhill. This one's going to be uphill. We're told that downhill it took 12 hours. The rate that corresponds to 12 hours is R plus G. And we know the distance is going to be 336. Similarly, we know the uphill part of the run took 14 hours. We know the corresponding rate is R minus G. And both distances are the same, since in this case they're going up the hill, and in this case they're going down the hill. It's the same hill. Okay, so let's go ahead and set this up so we can get a system of equations going. Again, that's going to look like this when we multiply this and set it equal to this. Again, this could be R times T or T times R. Doesn't matter how you do that. So let's do that. We have 12 times R plus G equals 336. And here we have, and let me give myself some space. Here we have 14R minus G equals 336. Like in the problem where we dealt with the boats, we can multiply this 12 to the r and the g, and we can distribute this 14 to the r and the g. Or we can go ahead and simplify this equation to make it easier to work with. And in this case, I'm going to go ahead and do that. I'm going to divide this side of the equation by 12 and this side of the equation by 12. Similarly, I'm going to divide this side of the equation by 14 and this side of the equation by 14. This is going to cross out, which will leave me with r plus g. That said, I have 336 divided by 12, which I have to work out using long division. 336 divided by 12. Now the question is, how many times does 12 go into 3? 3 is too small. How many times does 12 go into 33? 12 times 2 is 24. 12 times 3 is 36, which is too big. So I know this is 2. 12 times 2, as I just said, is 24. Let's subtract. 3 minus 4 we can't do. We have to borrow. This becomes 2. This becomes 13. 13 minus 4, as we saw previously, is 9. And 2 minus 2 is 0. We have to drop down this 6. 12 goes into 96. If you're not good with your 12 times tables, you might have to guess at it. But we should be able to see that it's going to be 8 insofar as 2 times 8 is 6. Carry the 1. 8 times 1 is 8 plus 1 is 9. So we know that this is going to be 8. 8 times 12 is 96, which is going to leave us with no remainder. In other words, 336 divided by 12 is 28. Let's go ahead and try to do the same thing for 14. 336 divided by 14. 14 times 2 is 28. 14 times 3 is going to be, 52. So we know that this is going to be, not 28, not 52, 42. So we know that this is going to be 2. 2 times 14 is 28. Subtract. 33 minus 28. Well, we can't do 3 minus 8. We have to borrow. This becomes 2. This becomes 13. 8, 9, 10, 11, 12, 13. This is 5. Drop down this 6. 14 goes into 56. It's going to be 4 times. You should know that 14 times 4. 4 times 4 is 16. Carry the 1. 1 times 4 is 4 plus 1 is 5. So we can see that we do 14 times 4. That will get us 56. So there will be no remainder, which will leave us with r minus g equals 24. Now we have our system of equations, namely r plus g equals 28 and r minus g equals 24. And in this case, we're not asked to solve for g. That would be irrelevant. But we are asked to find the rate of the speed of the runner on still ground, or on flat ground, which is just r by itself. So in other words, we have to solve this one using elimination. More specifically, we're going to eliminate the variable g. And to do that, we're just going to add these two equations together. So let me rewrite this. We have r plus g equals 28. And we're going to add the second equation to it, r minus g equals 24. Let's add. R plus r is 2r. G minus g is nothing. 24 plus 28. 8 plus 4, 8, 9, 10, 11, 12. Carry your 1. 2 plus 2 is 4 plus 1 is 5. Divide both sides by 2 since we want to get r by itself. That leaves us with r equals 52 divided by 2. Let's work that out. 2 goes into 5 2 times without going over. 2 times 2 is 4. 5 minus 4 is 1. Bring down this 2. 2 goes into 12 6 times. 6 times 2 is 12, so there's no remainder. So therefore, we know 52 divided by 2 is 26. In other words, this runner is capable of running on flat ground at a rate of 26 miles per hour. And in getting this 26 miles per hour, we've solved this problem. Okay, so that's all I have for you in this video. I hope you find it helpful. As always, if you find my content helpful, please subscribe to my channel. Believe it or not, that does help my channel grow. In addition, you can always leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.